It's about piles because I would say that pile is the most common geotechnical structure that you can find everywhere in the world. I would say the basic was somewhere in, I would say Neolithic, or somewhere 10,000 years ago we can find the first file. Here on the structure you can see that Roman machine for driving piles. Here's a picture from Rembrandt, how to make piles in Netherlands. So it's very old structure, well known and used for 1,000 years. And I have to say that the analysis of piles is still, I would say, the most complicated, and good predictions of the real behavior of piles are pretty difficult. You know, if you do design of concrete steel, it's, I would say, exact. There's some difference, several percent. If you do design of, I don't know, wall, spread footing, still we know that bearing capacity is like this, and it's plus minus, I don't know, 20%. In pile, you have one method, bearing capacity is 1,000, second method, bearing capacity is 2,000, third method, bearing capacity is 5,000. The difference in the results are pretty high, and it depends usually on local experience, because you usually should know your soils and type of construction, and the same geological survey, the data that you have about the soil and from what you compute the bearing capacity. So that's just one funny thing that I want to show you when I prepare for some presentation about piles. We look to the software commercial that you can buy in the world, and you can look to the method, and we find out that we can easily define 50 different methods how to compute one single stupid pile. And you have about 40 different programs that you can use, and usually one method is in one program. So every time you can say we are computing well because we have this input and we have this result. If we look at the method, we find out that only several methods are in more software. So here, if you have a CPT, it's very well. At first, Eurocode 1992 is the same method, in fact, as a Dutch NEN method that compute bearing capacity of pile from SPT tests. The second one used is LCPC or Bustamante method, is again from the CPT tests. And then you can see Tomlinson, it's very often, it's just for clays and total parameters of soil, where you know shear strengths of the soil, and that's enough. All other methods are usually in every commercial software once or two times. So it's a bit complicated. So in GEO5 we have for file foundation analysis several programs. It's BioCPT, and this one we show, and it's, I would say, very nice and easy program, but you have to trust the result. The results are correct according to Eurocode or according to NEN standards, but how much they are good, I'm really not sure. I would say all Netherlands is computed and built with results of this method, so I believe that it works. But personally, I have no experience with that. We don't use it in Czech. Then we have a program pile. Program pile is the program that compute bearing capacity of pile from, I would say, traditional soil properties as a friction, cohesion, and I would say the method here you have some bearing capacity of base and some bearing capacity of shaft, and together is bearing capacity of pile. Another program is pile group that we have if you have more piles. Usually below abutment you can use this, and of course theoretically you can use micropile or you can use fine element axis symmetry, but it's not so common. So in our programs you can compute vertical bearing capacity of piles, settlement of piles, or load settlement curve, because in fact no pile has bearing capacity. It's usually bearing capacity means that it's bearing capacity for some settlement. We are, for example, in Czech and in many other countries, we usually take the limit 25 millimeters. So bearing capacity is very often defined as a load that we have to the load we have to apply on the pile that we receive 25 millimeters settlement. Sorry. Then we can compute horizontal bearing capacity. There are two ways. We can use PY method when we introduce some models of superate reaction, or Brown's method that is used in, I would say, Anglo-Saxon countries as England. This is used very much in India, New Zealand, Australia, when you compute the horizontal bearing capacity of pile. And of course we can do a dimensioning of RC piles. So now I would ask Boris to show you how to make design with program ICBT. I suppose he will start with a video that we have in video tutorials. We finally fixed the problem, so find it.
No, pak můžeš.
So, as my colleague said, we fixed problem with sound. So now I can show you our video tutorial for pile CPT.
This tutorial shows how to design a pile based on the coal penetration test, or CPT. We will perform an analysis according to the Eurocode standard EN 1997-2. Firstly, we must check that we are proceeding in accordance with the Eurocode standard, which can be set in the settings pane. Then we load the CPTs, which are our primary input. The tests can be imported in different formats, either in the text format or other defined CPT formats such as GINT, CPT, or GEF. In our example, we will use the Dutch GEF format. We will select CPTs that we want to import. The calculation can be based on one or more CPTs. On the screen, we can see the distribution of cone resistance, local friction, and core pressure. The data of both imported tests can be viewed. Next, we will input the groundwater table, which should correspond to the imported core pressure. Then we will move to the classification of soils. The program enables us to automatically classify soils and soil layers according to Robertson's theory. There are two possible procedures, one from 1986 and another revised one from 2010. In the case of very thin layers of soil, it is appropriate to choose a minimal soil layer thickness. So if we choose a layer thickness of 0.5 meters, we get a simple neat geological profile. This profile can then be inserted into the program, so we don't have to input the profile or soil parameters. frame construction, we select the type of the construction, single file, and input the service and design loads. In the frame geometry, we select a circular pile and choose the board pile with steel casing. Now we can run the calculation. Here we can see the total resistance, the bearing capacity of the pile, which in our case considerably exceeds the given load. This pile could therefore be edited from an economic point of view. We could, for example, shorten it or make its diameter smaller. In the frame settlement, we can see the load settlement curve based on the given load and the calculated pile settlement for the given service load. The design of the pile is now complete. More information can be found in other video tutorials, online help, engineering manuals, and verification manuals.
So
Should you have any?
it is very easy to design pile in program pile CPT, as you can see.
don't have CPT.
If you have CPT results. Yeah, exactly. So now I would like to show how to design pile in program pile. So this is program for single pile. The beginning of our programs are the same. You now first set your settings and information about project if you want. And here in pile you must to choose your analysis method. So if you want analytical solution or Spring method, first we try analytical solution and then analysis type. So next one is everything about geology. I open a file or the demo exercise. Setting is analytical solution and analysis for drainage conditions. Now next part is define geological profile and assignment of soils. So next part is load. You can import it from static programs, from SIA or Dubar or something like that, from TXT or Excel files, and or you can define it on your own if you want. Next part is you can consider the cell weight of pile. This is a really good advantage for result. So now we can input our geometry. You can define your cross section. You can choose circular, pipe, square. It depends on material. Pile diameter, pile length, of course. If you want concrete or timber for circular. If you have pipe pile, you have concrete or steel. It is changed depending on cross section type. So we have cross section and concrete and technology classical board pile. Location, pile head offset, it means how high is head of pile over the final grade. For example, it could be half meter. And depth of finished grade is same as original ground. So next, material, define properties of material, of concrete, and of course of reinforcement. And if we have from geological survey water table, we can input it here. And now final input is design situation. There is a permanent design situation. So first result is vertical capacity of this single pile. This is a result for the worst load you've been set it in frame of loads. Of course you can choose your load, for example this one, load number 1. If you have another design load, you can show results for this result. This is automatically, and this is for the worst load what you have on your pile. And of course you can see it in details. Next part of results is settlement. This load settlement curve to 25 millimeters. And last important thing in horizontal loaded piles is reinforcement. Now you can see the internal forces and displacement of this single pile, and here you can design a reinforcement of this pile. It's very easy, as you can see. You can find you can choose your load or just find maximum values automatically and just take profile, number of bars. I can change it, for example 22. Number of bars, for example 8, and cover this distance between side or this side of pile to reinforcement. It was really easy, as you can see, and now I would like to show you next program, and this program is pile group. So we can open pile group. Now I often open demo manual because of time, and now we have 2 or 3 analysis types. We have analysis solution, and result is just vertical capacity of this group of pile, just vertical capacity, no internal forces to each pile. The next method is spring method. This method, the result is internal forces on each pile, and you can make a dimensioning of each pile, and of course you can do a spring method for micropiles, what is very similar. So I would like to show you an analytical method for this exercise. In frame structure, you define your horizontal cross-section of this group of pile. So you can have circular, ellipsoid, or you can generate your own shape if you want. We try this square. Second part is geometry. This is length, this is how high is pile cap, or thickness pile cap, long piles, pile head offset if it's possible. Offset of piles, and then you just define your materials. This is for concrete, and of course load. Just import or add manually, as you see. So second part in this program is geological profile, and this is the same thing as you saw in previous programs. So just define profile, soil, and then assign soil to the profile. If you have groundwater table, just define it, and last thing is stage settings or design situation. So results for analytical method is just vertical capacity, and if you want, you can see a vertical capacity of this group of pile, and of course settlement and load settlement curve. For example, if you want to design reinforcement to each pile, you need to open next exercise, and this exercise was made for spring method. So now you can see we have here dimensioning, and everything is the same. Load, water, vertical springs, and into analysis. Into analysis you have 3D view of internal forces or normal forces, bending moments, you have deformation or rotation, pile cap, and of course you can see displacement on each pile in all axes, X, Y, and Z. And of course you can choose your load results for load you want, or just for pile you want to see. Just one or all of them. It's really easy. And second thing is dimensioning. Now we have internal forces, so we can make a reinforcement for each pile or all piles together. It's on customer, it's on you, it's on designer, or it's on user. You can choose result or load, or you can choose pile if you want. But there is reinforcement for all piles, so it means reinforcement is the same for all piles from beginning, from our tasks. And bearing capacity is did for the worst loaded pile, and it is just open piles for single pile program, and just you have results for bearing capacity of single pile. Everything is correct, and we have this is the end of presentation.
Okay, I done something.
Yeah.
So, what my colleague showed is very important to have. The group of a pile works just for the piles. There's a, I would say, slab or the cap is really stiff, because we don't compute with deformation of the cap. We compute just with the forces in the piles. So if you have a slab on the piles, mat foundation, it's possible to use program slab and define piles as springs, the springs below slab. So if we go back to the program pile, you saw that it looks very easy, that we input just geological profile, click on bearing capacity, and you receive just one result. It works in spread footing. In spread footing, in walls, in slope stability, you can be sure that it's correct. As I told you, here you must be very careful about the chosen method. You have to know this method, and you have to understand it and to know how to use it, because here you can receive really strange result. The method that we have inside, you can choose here. We have the Tomlinson, NAFAC, or elastic subsoil. It's different methods for drained and undrained condition. Only NAFAC, it's American method or found in American literature, can combine effective and total stress in different layers. So somewhere you input just effective friction, in another layer you can input shear strengths, and this gives you some results. If I return to my presentation. Oh, sorry. get back to the question, what program to choose. So the first question is what type of construction you have. Is it a single pile, group, anti-slide pile walls? And what verification you need if you are interested just only in vertical bearing capacity and you have a CPT test. Use CPT and pile CPT program because you can receive the results very fast. If you are interested in horizontal deformation and horizontal bearing capacity, you have to choose another program. So we have you can find it in our documentation, just a table, what program to choose and what you can compute in what program of GEO5. I just want to I skip it very fast. Pile CPT, how it works. So in pile CPT we have several methods, as mentioned, 6743. Dutch method, I would say that by test of time it works in Netherlands for about 20-30 years and computed very much. In fact, Eurocode 1997 passed 2, except that Dutch standard the same way as it is. If you open the Eurocode, it fascinated me that they took even the same figures, same pictures without any changes and put it to Eurocode. And to have some difference, I suppose they change that 3 partial factors by several persons that we can say that it's Eurocode. Then we have a French method, CPC Bustamante. It's the way how they compute this type of piles in France. And then the last one, the Schmartman method, that is used in the United States. And for user it's very simple to use because you just run the program and receive result. But what's a bit problem when we look to the results? Sorry, it was a pretty long presentation. Comparison of results. We did a test that we have some geological survey in northern Bohemia. We have 2 boreholes and 2 CPTs next to that. So we had more column parameters and we have CPTs from the same place and profile. And we tried to compute this, some design, some wall, some pile. And here you see the result from the first borehole. And you see that results for the same CPT differ from 2000 to 3300 and settlement from 8 millimeters to 27 millimeters. So when we look at it, we say, okay, that's clear. LCPC and Schmartman give more conservative results. But next I took the second borehole, second CPTs. And you see that the results are completely different. That LCPC has the highest bearing capacity and Eurocode and Schmartman much lower. So that what I want to say that in piles you must be very careful and to know very well what you are doing and what soil properties you have, and you have to have some experience with this type of construction. Here you can see that I would say the result of my old presentation. Here you can see all methods that we have in GEO5, and we tried to calculate pile the best way that we can. And you see that we have about 11 different ways how to determine it, and the bearing capacity is between 1,300 to 3,400 and similar settlement. So that I wanted to show you that sometimes when it looks nice and easy friendly, so the reality may be different. And I would say that no one can tell you which of these results is correct and what not. The prediction is somewhere between it.